So now this is question 2 of the paper for physics 1010 2024 exam past paper. So the question is saying a ball, that is part a ball at the end of a 2 meters long string swings in an arc as shown below. The ball speed is 3.5 meters per second as it passes through its lowest position. To what height h above this position will it rise before stopping? Part 2. What angle does the string make with the vertical when the ball is at the highest position? Now, it is very important for us guys to first look at the diagram which have been given. So this is more like a simple pendulum, but we need to understand some certain concept. So the first thing I want you to understand is that this length which have been given here, the length which have been given is 2.0 meters. Now this 2.0 meters is this one which you have there. But at the same time, if I can take this, I bring it back, it is basically the same as this length. So this is also L. Everything from there all the way to that position. Okay? Meaning that for me to find this part here, it's going to be L minus H, of which I don't know H for now. So let's get this to be X. Meaning that for me to find X is going to be what? For me to find X is going to be L minus H. But the first question is asking us to find the H. So let's go. Now, one thing again we need to know and understand here is that we want to find the H. The question, from the question there is saying, the ball's speed is 3.5 meters per second as it passes through its lowest position. Lowest position is this position. So as it was passing this position, the speed is 3.5 meters. Okay? The speed is 3.5 meters as it was passing here. Then when it reaches there, it came to stop. It was just there. And that's where now we have got the distance, the height. Meaning that at this point here, we have kinetic energy. We don't have potential energy at that point because it was moving and the height is 0 at this point. So if you want to make things simple, you can say this is point A and that is point B. So at point A, we expect to have only potential kinetic energy because the ball was moving at that point. And it is at the lowest position, H is 0. So we expect to have potential kinetic energy only. At point B, it was not moving, but there is height, meaning we need to have what? Potential energy at that point. So therefore, you say kinetic energy at point A should be equal to the potential energy at point B. That is conservation of energy. Conservation of energy. So conservation of energy is that energy cannot be created and it cannot be destroyed, but it can be converted from one state to another. So the energy which we have here, when it reaches at point B, is going to be converted to potential energy. So I'll say half mv squared being equal to mg h. We do not have mass, we can cancel mass, or mass appears to be everywhere. So my goal is to find the h. Half v squared is equal to gh divided by g divided by g. So h will be equal to half v squared you divide it by g. So h will be equal to half, the velocity is 3.5, now we square it, we divide it by 9.8. So what will be h? So if I go back here, I find my h, I'll discover that I will have 3.5, I square it, times 1 over 2 is 0.5, I divide it by 9.8. So I'm getting my h to be 0.8. 625 meters. If you want, you can round it off and say 0.23. It's okay. That is just fine. It's all right. You can do that. So that's the answer for the first part. Now we move to the second part. So the second part now, we can clearly see that it's asking us to say what angle does the string make with the vertical when the bow is at the highest point. So when the bow is here, what angle? So now here, one thing we should know is that I'm going to use SOHCAHTOA. So we definitely know that this is the hypotenuse, this is the opposite, the angle, and this is the adjacent. So I have the adjacent because for me to find x, adjacent is x. So for me to find x, it's definite L, which is 2 minus h, which is 0.625. So my x is so I do minus 2, my x is 1.375 meters. So which one am I going to use? Not for the opposite, but I'm going to use cos, because cos is adjacent over hypotenuse. I don't know opposite. So opposite, if you want, you can also find using Pythagoras theorem, but it's going to take time anyway. Okay, then when you find the opposite, you can use tan if you want. You end up having the same one. So in this case, I'm going to use cos. So I'll say I can now get rid of this. I'm going to say cos theta is equal to, what is cos theta? Cos theta is adjacent divided by hypotenuse, of which we know that adjacent is x. I divide this by the hypotenuse is L. Now my goal is to find the theta. I'll divide both sides by cos. So therefore theta will be equal to cos inverse of x divided by L. I want you to know this. When I divide this side, it will be like this. X divided by L times cos times 1 over cos theta. So 1 over cos is the same as cos inverse. That's why I've put cos inverse here, in case you don't know. Now at this point, I can now plug in the values. So I'll say the theta will be equal to cos inverse. My x is 1.375. My L is 2. So let's see what will be our theta. So shift, then cos, open brackets, 1.375. Then I divide this by 2. Okay, so the angle I'm getting is 46.567. 46.567 degrees. To make things simple, let's just round it off. So it's 46.6 degrees. That's the angle. So that is it for question 2A. So it's just a matter of you understanding what is happening, and it's very easy. Okay.